Thank you so much for joining us today. This is the second in a series on serving humanity with space data, co-hosted by the Space Enabled Group and the Secure World Foundation. My name is Crystal Azelton, representing the Secure World Foundation. For those of you who are joining us for the first time, this virtual series aims to engage a multi-sector audience in discussions on how space technologies and other geospatial applications contribute to better outcomes in critical fields around the world, such as energy, food security, poverty, governance. We're hosting this twice a month, and the events will bring together stakeholders working in companies, nonprofits, academia, and government to highlight initiatives taken to make progress towards the 17 Sustainable Development Goals. We're trying to highlight real-world case studies, as well as new opportunities and the challenges faced by practitioners for expanding the use of satellite data in efforts to achieve the SDGs. This series seeks to take a look at ongoing work by a variety of actors, but with a special focus on development and humanitarian projects. Today's session will focus on SDG 16, Peace, Justice, and Strong Institutions, which seek to promote. This webinar will highlight projects that have incorporated Earth observation data to better understand and take action to end violent conflict and human rights abuses around the globe, as well as other examples. With that, I'd like to dive right into our exciting lineup of speakers today. And I will share our presentation. All right. So without our first speaker is Einar Bjorgo, who is the Director of Satellite Analysis and Applied Research for the United Nations Institute for Training and Research. Turning it over to you.
Thank you, Crystal. Thank you so much. And many thanks to the organizers for inviting me to this event. This is a topic that has been gradually expanding over the last couple of years. So I'm happy to be able to present the slides and do this presentation. So yeah, please go ahead. Thank you. I'm the director of UNOSAT. This is an entity, part of the United Nations Institute for Training and Research. We're based in Geneva in Switzerland. And today I would like to give you a few examples and some maybe a little bit food for thought on how this issue of satellite imagery can be used in terms of not only overall to the Sustainable Development Agenda, but also in terms of specifically for Goal 16. As you see from this little graph here, my institute, or UNITAR, the UN Institute for Training and Research, has been, let's say, Agenda 2030 adapted. So we have divisions for peace, people, planet, and prosperity. And then we have a couple of cross-cutting divisions, of which UNOSAT is one. So next slide, please. Thank you. So we've been operational since 2001. We are based in Geneva, and we are hosted by CERN, the research laboratory. And thanks to them, we're able to really make use of this technology, because in terms of data storage, bandwidth, etc., the satellite imagery requires a lot of technical support and IT support, and we get that from CERN, so we're very pleased with that. Within the UN, we are sort of the only entity that is fully dedicated to satellite imagery analysis and also capacity development on that. And this also applies to peace and security issues, not only other development issues that we're working on. And frequently we are, have the team of practitioners also doing the capacity development. The capacity development are typically done in order to help governments make more use of this technology. Next slide, please. So I wanted to show you some examples just to get started here. So what you see here is Mosul in Iraq on back in 18 February 2017. Now what you see here, if you look at the image, you can see the colored parts there are basically markets, and you can see quite a lot of activities on the streets, etc. in the lower left, for example, outside of the markets, and sort of a bustling city. Then, next slide, please. Then the coalition forces, and is sort of one of the final battles of ISIS, led to a vast destruction of the city. Now, this type of information, of course, can be then monitored using the satellite imagery. Now, what is important here is that, to monitor this, there are so many issues at stake. We are not only doing this from a pure humanitarian perspective. So when we are asked from our UN sister agencies with a proper mandate for this, in terms of humanitarian relief, in terms of protection of civilians, etc., then we are basically responding to their requests. To do so, we often need to have a quite specialized analyst making this analysis. So if you click on the button, you'll see a little zoom. Yes. So also just to zoom in a bit so you can see the complexity in this type of destruction. So this means that in order to see if what has actually happened in the city, how bad is it? And this is of course an extreme case, but quite often you also have to be very subtle in terms of the type of damage that we observed. The buildings, what kind of ammunition has been done? Is there a danger for unexploded ordnance, etc., in the area when the relief personnel moves in? So there are many aspects that our analysts at UNOSAT need to make sure they cover, basically, in this type of analysis. Then if we go to the next slide, it's a little video. So I will let the video speak for itself. This is basically how the UN Refugee Agency has used
imagery that UNITAD is providing in the context of the Syria crisis, where we're seeing scores of villages engulfed with conflict in southern Syria, which is resulting in hundreds of thousands of people fleeing towards Jordan. We're also using it to map out the refugee camps in Jordan. We've been seeing the progression of the Zartri camp over several months. And we're able to use the analysis which was provided by UNISAT to describe how many new tents have been set up just in the last month. We're able to have a calculation of how much land was still available to construct additional tented sites. So it's extremely useful to receive this type of service from UNISAT, not only the satellite imagery, but the analysis, whether it be from the planning process to the response to the evaluation. Satellite imagery is indispensable and will become the norm rather than the exception.
Yeah, thank you. So if you take next slide, so please keep in mind that what isn't, I think, is one of the great benefits here of this technology is that you can both support, the very detailed field, like in the previous case, camp management, refugee camp management, and really support the boots on the ground. Then what we also quite see more and more use of is this type of information being used at the highest level in international diplomacy. So this photo is the UN Emergency Relief Coordinator, Mark Lowcock, who's basically just briefed the Security Council in the UN. This was almost a year ago during the battle over Idlib in Syria. And really showing, with proof how bad the situation is. And this is, I think it's important to have this notion that this type of analysis, the type of imagery is both useful, for practical problem solving in the field, but also more, let's say, at a higher level of international affairs and in peace negotiations, etc. Next slide, please. So in terms of how this type of information then can be used for informed policy decisions, I think it's extremely important to keep in mind that one, this is objective information. Of course, you can always discuss the way the imagery was analyzed. That can be skewed, let's say. We are, part of the UN, so we do a pure technical analysis. Everything is transparent. So if anyone, has would like to redo the analysis, we will simply point them to the image, and anyone can do the analysis themselves. So we're very transparent in that manner. We only use imagery sources that can be verified, which means that quite frequently we use the commercial commercial satellites, both US satellites, but of course also French, Chinese, Korean, etc. So we try to be very diverse in the types of imagery that we're using. Another great benefit is, of course, that it covers inaccessible areas, obviously. So you do get information also in near real time, if need be, over the inaccessible areas. In addition to that, we can also go back in the past, which is quite often the case when we have questions of human rights abuses. We need to go back in time to look at what was the situation, how did it evolve over time. This is, for example, something we have been doing not only for the Rohingya case, but also previously in many aspects. So the time travel and also couple that with ongoing monitoring is also very important. And then, of course, the high level of details that we can get today down to 30 centimeter resolutions. And of course, also extremely important that the images are timestamped, so we know exactly when the images were. Next slide, please. So in terms of the opportunities, how can we expand this technology? Well, we would really like to see this used much more, obviously. And I think one important aspect to this is simply awareness raising. Still, a lot of people are not really aware of what the technology can do. And one good example in that sense, I think, also is the European Space Agency funded Earth Observation for Sustainable Development, let's say, series of projects. One of the projects is linked to fragility, conflict, and security. And in that sense, we have developed an online e-learning course, which is free. It's in French and English. It will soon be also in Arabic. And this is sort of a low-level entry to how this technology can be used in this type of context. So I think that's also, a quite important way of being able to communicate and have more people understand what the technology can do. And of course, also in terms of improvements in the technology, with we see it's easier access to data, much cheaper data than what was the case before. So also NGOs will have budgets to make use of this type of data, because in the future, basically we're talking about a turnaround time of 90 minutes from request to downloading the imagery, thanks to satellite constellation, and also keeping in mind that the prices are dropping. So that is where it's really getting interesting, and I think we have a huge opportunity here. Next one. So, but there are of course also challenges, in terms of what we have experienced at UNOSAT when it comes to human rights and governance projects. We sometimes see a crash of cultures. We have very engineering type minds in terms of satellite image analysts, and then sometimes, we face lawyers. How can we make sure that what we do fits their language and their understanding? And that is really up to, most of the time, I would say it's up to us to learn, because much of the Earth observation community seem to have over some time had the approach that here's this great technology, now why don't you all use it? But it doesn't work that way. You really have to understand how it can be used. And to do that, that takes time, and you have to dig into it. And sometimes you fail, but then you learn from that. But it's true that I think having that, bridging that gap and really taking the time to understand what you can do with the technology and learning also from others, that is something that is extremely important. So we have also been working on this. I sit also on the pleasure to sit on the International Criminal Court Office of the Prosecutor's Scientific Advisory Board, and these are things we're discussing. How can we also raise awareness even among the judges at the court? How can they better understand what this technology can do? And then, of course, is data availability. Sometimes, especially going back in time traveling back, sometimes the data are just not there, and they're not there at the sufficient resolution. However, this is an aspect that is greatly improving and will be much less a problem going forward. Next slide. So that's, I just wanted to summarize a bit, now, just to say that this technology, we have seen a huge surge in interest in what we're doing, especially in this field over the last couple of years. And I think that's not going to diminish now with the COVID situation, where a lot of people who have else, not normally would find its way to think about satellite imagery, but since it is this has the benefit of being able to acquire information over no-go areas, a lot of people are starting to realize the benefit of this. So thanks again to the organizers, and really happy to be part of this webinar, and looking also forward to learn more of the presentations from Jamon and Doreen as well. Thank you.
Thank you so much. Before we move on to our next speaker, I do want to remind everyone that we will be taking questions at the end of this session. So please feel free to log on to Slido, and you can type in SDG 16 as the code for this meeting. When we get to the end of the presentations, we'll be turning it over to your questions. Now, I'm very pleased to introduce our next speaker, Dr. Doreen Boyd, who is the Rights Lab Associate Director with the University of Nottingham. She's here to talk to us today about their Slavery from Space project. Doreen?
Okay, thank you very much, Crystal. And many thanks for the opportunity to be here, to be involved, and I'm honoured. Yeah, I'll kick off with the slides. Brilliant, thank you. Okay, so I belong to the Rights Lab, which is primarily an academic outfit based at the University of Nottingham. And we're home to the world's leading modern slavery experts and have built a large-scale research platform for ending modern slavery. In the lab in the UK, we use the term modern slavery as an umbrella term for modern slavery itself, forced labour and human trafficking. We're the world's largest group of modern slavery researchers, and we're home to many leading modern slavery experts. We have 5 research programs, and throughout those research programs, we aim to deliver new cutting-edge research that provides rigorous data, we hope, evidence and discoveries for the global anti-slavery effort. And we do this through our Modern Slavery Evidence Unit, which is the interface between the research that we do and civil society, business and government. So it works very closely with stakeholders to address their evidence gaps. We also have an Inspire project which elevates survivor-informed research as a key part of the knowledge production to support survivors to achieve full freedom. Next slide, please. We fully appreciate the goal of ending modern slavery is ambitious, but in the Rights Lab, we believe that by working together as part of the global anti-slavery community, we can achieve evidence-based strategies to help end slavery by 2030, i.e. as set out by the United Nations Sustainable Development Goals. Obviously, having the right data and the approach to their analysis is extremely important. And this is the concern of the data programme in the lab. And one of our projects within this programme seeks to exploit Earth observation data from satellite platform to meet some of the data deficits relating to the UN SDGs concerned with modern slavery, i.e. Target 8.7 to eradicate forced labour and modern slavery and human trafficking, and 16.2, which is end abuse, exploitation, trafficking and all forms of violence against and torture of children. Next slide, please. We aim to use the plethora of Earth observation data out there, both open data and commercial data, to provide information deemed required by our partners in the anti-slavery arena. Put simply, what we're doing at this stage is looking for objects of SDG intersectionality. So essentially, these are sites where we know that modern slavery is occurring or have occurred, or where the sites that traffic may well end up. So, for example, we have brick kilns, illegal logging sites, fish processing camps, and artisanal mines as these objects of SDG intersectionality. What is key here is that these objects appear in EO data, but they tend not to be mapped by the authoritative agencies, as their significance is not yet realised. And as we've been studying these, we've further realised that these sites have a significance for other SDGs, not just 16 and 8. For example, brick kilns using bonded labour have been known to use more polluting raw material during brick production. And of course, this intersects with SDG 13 and 15, i.e. climate action and life on land. Mined resources using child labour make their way through supply chains, and therefore that intersects with SDG 12, i.e. responsible consumption. Next slide, please. So what I want to do for the next couple of slides is to go through some examples of what we've been doing. And the first one on this slide relates to our spatial temporal mapping of the Bull Trench brick kilns across an area which is known as the brick belt across South Asia. These kilns have been reported for years to use bonded labour, but the scale of the problem was unknown. So put simply, there was no knowledge of exactly how many of these kilns there are, where they are, and their temporal evolution. So we partnered with Airbus and used the very high resolution data they provide to map every single kiln across the area, which is around 1.5 million square kilometres. And then once we knew where all the kilns were, we then used the Landsat data to go back in time to understand when they were constructed. And these data are now being used by the United Nations Development Programme Accelerator Lab India in their work on the ground in addressing concerns with these particular kilns. Next slide, please. So this second example focuses on cobalt mining in the Democratic Republic of the Congo. So we've received some funding from the British Academy for an academic and activist, Siddharth Kara, to spend some time working with us and with the EO data we've acquired across this area. Siddharth himself has visited the DRC and documented the use of children in the artisanal mines. They're used for tunnelling down into the ground. But again, we do not know the scale of the issue. So we've been using both optical, but also what we call synthetic aperture radar data to map these tunnels and also to work out if the tunnels are active. In this project, we're working with an activist who is raising the awareness of the issue of tainted cobalt in the supply chain. This mineral is used for lithium-ion batteries. So this does have implications for some large companies. Next slide, please. This example relates to the exploitation of migrant workers in the Neo-Manalada area of Greece. So we've been working with local NGOs using EO data and to model the likelihood of the occupants of identified camps in the area to be exploited. So this information had been taken forward by the Greek Special Rapporteur on trafficking in human beings. And the idea of using modelling via EO data is now included in an action plan of Greece's response to prevent any exploitation of migrants going forward. Next slide, please. I'm hoping with these examples you gain a flavour of how we're dovetailing our research endeavours in the Rights Lab with the demand, sometimes latent, from the wider anti-slavery arena. The work we do could purely be an academic exercise, realising the use of deep learning methods or interferometric SAR or the optimal exploitation of citizen science data for working with the EO data. But the whole premise of the Rights Lab is for our research to have impact, i.e. be useful. This is, as one of our colleagues, Austin Show Fitzpatrick, notes, about team science. It's about dovetailing all the stakeholders involved in addressing this issue. But more importantly, we do need the ground intelligence to make this work useful. So this is eloquently put by Andrew Zoli from the satellite company Planet, where he said the imagery itself is dramatically less worthwhile if you don't have local knowledge of what you're looking at. So the biggest challenge for us really is, how to optimally connect the ground segment with the space segment of the work we're doing. So far we've been very fortunate in the lab that we have a working blend in the way we do. We've been able to provide our EO data with the right organisation. But of course, there's always questions around privacy and surveillance, use and abuse of data, data quality, and its update and timeliness. Furthermore, the problem we're tackling is dynamic and evolving. Just look at the current pandemic and what that might mean for the vulnerable. The bigger challenge for me is we're still a long way from fully optimising what is possible with regard to using Earth observation data for human rights per se. I have a vision that we have an initiative along the lines of the International Charter for Space and Major Disasters to address SDG 16 and also those intersecting SDGs such as 8, 13, 15 and 12. So I guess time will tell.
Thank you so much, Doreen, for that incredibly useful presentation. I was really pleased with how you were able to highlight how different types of satellite data are used in different ways, but also the intersection between ground information and the relationship between that and using satellite to get information that would be almost impossible to collect at a ground level. I'm pleased to also now introduce our final speaker. Demon van de Hoek will be speaking to us about his conflict ecology project. Demon?
Thanks so much, Crystal. Would you go ahead one slide, please? So thanks a lot to Einar and Doreen. Those were really great presentations. And I think that what I'll be talking about segues really well from where Doreen ended. So I'm continuing this discussion of satellite remote sensing for SDG 16. Most of my work within this area focuses on using different kinds of satellite sensor technology to study the effects of violent conflict, but really how those violent conflict events are manifest on the landscape. So in many ways, the work that we do in the conflict ecology lab and my individual research focuses on using the landscape as a medium for gauging the effects of conflict in the short term and the long term. And we use satellite sensor data as one of the different kinds of data sets we can bring together, really as a prism to understand the manifestation of that conflict. Because as Einar and Doreen have pointed out, this conflict is meant, these conflicts and associated processes of peace and justice are not just at one scale, right? They're at individual, household, family, community, and then national and global. So we need to work across different sensors, and I'll have a couple of different examples to showcase some of the work we've done here. Could you go ahead one slide? I'd like to start though from a pre-satellite era, just to show some of the sort of groundbreaking work that really guides the philosophy and the spirit of much of what we do in the conflict ecology lab, and that is the London bomb damage map project from 1939 to 1945, which sought to document damage across the city of London from mainly V1 and V2 rocket attacks. And you can see here in this map that these are hand-colored regions drawn on basically a surveying plan. At the building level, sometimes at the block level, sometimes at the plot level, different levels of damage are indicated. Here we can see black would refer to total destruction of whatever the feature was, whereas yellow, going down the spectrum, is really minor damage. This sort of goal of getting at this granular level, this isn't quite at the individual level, but this is at the household level, this is at the building level. This, as you've seen from the previous presentations, is still really a goal of this kind of work, is to bring this down to this scale where it is affecting individuals, families, and the decisions they're making and how they respond to different manifestations of conflict. If you could advance one slide, please. And hit play on that guy. Now, of course, we've come a long way since 1945 in terms of the different technology and approaches we have to monitor conflict effects. This is a visualization from a couple of years ago that shows the NASA Earth observing fleet. Now, these are environmental satellite systems, so a whole variety here. But within this sort of cloud of orbiting satellites are some of those that I'll be talking about, mainly the Landsat system, which is a NASA system. The benefit of working with satellite technology, one of the main ones is the fact that they orbit, they repeat, they return time after time, and in some cases for decades. Now, this perspective allows us to study long-term effects as well as repeat effects from a multi-sensor perspective of how conflict may be manifest on the landscape. And it provides a new perspective to understand not just the conflict event, but the chronology of conflict as it plays out over, in some cases, many, many years. Next slide, please. So I'd like to start with one example in the summer of 2014 conflict in Gaza. This is, some of these images are from a report that I contributed, led by Forensic Architecture and Amnesty International. One slide ahead, please. this first image here, we're at the Gazan border, and this is a 15-meter Landsat 8 panchromatic image. So this is an image that would, these are based on imagery that are basically black and white images. So they get all kinds of visible light coming to the image. And we've combined two of them, two different dates together here, such that the visualization where you see teals suggests a significant change from one date to the next, where you see red suggests a different kind of change, but also significant. And you can see most of the landscape is grayscale. Most of the landscape doesn't really change. But just between these few days here, about a week's time, we see these what appear to be sort of arterial pathways going into from connecting the south, which is broadly agricultural land in Israel, into Gaza, which, as you can see, is much smaller agricultural plots, much more densely populated, and the border is quite pronounced in this image. These arterial pathways resulted from different kinds of vehicles, different kinds of trucks, disturbing the ground on their movement into and out of Gaza. So we have a snapshot really of some of the pattern of this conflict. Next slide, please. Now that is with a public environmental oriented remote sensing platform called Landsat. Here, this is just a visualization where we've looked at some of the high resolution imagery that style that Einar was presenting. This is a Pleiades image, which has a 1 meter spatial resolution. So it's taken just about the same time. It's August 1st. Next slide, please. And all of these images are georeferenced. They all work together. They overlay with each other. So now we have a zoom in here. We were at 15 meters before. Now we're at 1 meter. And you can see, of course, much more spatial detail, such that not only do we see those same kind of arterial pathways, but you can see some of the plantations, some of the orchards. There's little teal dots popped out from that landscape. Those are individual trees that were removed as perhaps a truck. We don't exactly know, but perhaps a vehicle went through a single row and took down those trees. This pattern that we're seeing on the landscape is evident across many, many sites in Gaza during this conflict. Next slide, please. Another site showing a kind of a movement in action here, starting in the lower right-hand corner of the image. The vehicles went northwesterly and a northwesterly motion and tracked through different plots, crossed roads. Next slide, please. And you can see that we happen to capture this snapshot just at the right time where we can actually see the individual vehicles basically en route from this pattern of change that we just that we've seen in the landscape. These teal pathways, these are the vehicles that drove through these different fields. Next slide, please. So those were examples of before after, a series of before after sequences using high resolution imagery, as well as Landsat 15 meter resolution imagery. Now I'd like to look at a different kind of conflict altogether, which is now approaching towards a decade long, the Syrian Civil War, which started in March 2011. This kind of conflict is, the protraction of this civil conflict is not uncommon. Large-scale conflicts like this don't tend to flare up overnight. We need hundreds of images to study the progression of this conflict. And critically, compared to the Gazan example I was just showing, that was a very acute event, right? It had a start date and an end date within the specific event. Civil wars don't work that way. We have long-term, we don't know necessarily when things are happening. There's an abundance of information about how things are happening on the ground at different locations at different times. But that sort of detection approach that we were working with in Gaza doesn't really work quite as well in a long-term civil war, simply because we don't know what we're trying to detect. We don't even know what's there to begin with. It's many times, as in the case of Syria, large-scale, national-scale conflicts that play out at different populated areas, like Aleppo. And we need to kick into a monitoring mode instead of a detection mode. We need to observe and take in all of the imagery. Well, what I'm going to be showing is taking in all of the imagery and trying to identify changes as they play out, which we may not have any idea that was occurring in the first place. And we may not even have a means of validating it either, right? There's always information scarcity in these kinds of conflicts. So here's one date, June 18th, 2013, towards the very beginning, really, of the conflict. Next slide, please. Here we are 16 days later. Doesn't look that much different. Next slide, please. 16 days later again. And then next slide. Again, not much difference, right? 4 slides, 4 dates, each 16 days apart. Next slide, please. We can measure the change between these and start accounting for these changes that we see that are not necessarily that visible when we're looking across the full area, but pixel by pixel and really clusters of pixels can pop out these hotspots of damage. So here's the first, just a simple difference map from one date to the next. Next slide, please. And again, for the next sequence of images. Next slide, please. And again. Now, when we do this over and over and over, we can look at several hundred images, not just over Aleppo, but over the entire country of Syria, because this particular kind of system and others like it allow us to have what we would call wall-to-wall coverage. There's no patch of land within the country that we wouldn't have an image for. There may be a cloud there blocking our view, but at least we had an image. This allows us then to scale up this study, of course, not just at Aleppo, but across other major populated areas in other civil wars at other times. And when we look at these changes over many, many years, next slide, we can start understanding the composite. We can start understanding the repetition, the systematic pattern, the systematic expression of conflict on the landscape. We can look at areas that were targeted multiple times that showed damage, not necessarily day after day, but perhaps a dozen times, significant damage over the course of a year. There's been a whole host of different journalist reports on, and human rights reports as well, on targeting of medical facilities in the Syrian Civil War. So this comes out, and next slide, please, in this kind of composite damage map here, where this cluster, I don't quite have a pointer ability here, but one of the brightest clusters in the bottom right-hand corner there is a hospital complex. And we see that it's been targeted over, exactly, thank you, Crystal, over a dozen times during these couple of years of imagery. The rest of the city, we see these dark black or very dark gray tones, which suggest very little repeat damage, but certain areas really pop out of the landscape as being targeted over and over and over. That's the kind of pattern of systematic behavior that's relevant for human rights abuses, that's relevant for war crimes trials, that's relevant for understanding why populations leave and when they decide to leave. That's relevant for understanding IDP flows, refugee flows, aid delivery, right? It looks at, it brings us down to sort of this question is, why are certain areas being targeted repeatedly? There's some strategic or some other factor there that could be at play for human rights. Next slide, please. So these long-term repeat landscape level monitoring approaches are a bit of an underexplored resource for monitoring SDG 16, in part because there is a bit of a repositioning of understanding what we're going for. They cannot provide individual building level detection, or we're not measuring at the human scale. We're not looking at 1 meter or half-meter resolution. But we have decades of these data. This allows us to develop a historical baseline of typical change, which is really important when we want to rule out false positives, or false negatives for that matter. We want to rule out areas that always are changing in a certain way, dynamic areas that are unrelated to the conflict. That historical baseline gives us that framing that can support that. The second bullet point here, when we have the same system taking data year after year after year after year, that gives us a stable perspective, so we don't have to worry about making different systems click together, which may have different spatial resolutions. They may have different sensitivities to the sort of characteristics on the landscape, what we would call spectral or radiometric resolutions in these imagery. And all of these things can usually be worked with, but we have this opportunity just to start from the get-go with a single system that's continuous. And there's effort between NASA and European Space Agency, ESA, to harmonize these Landsat products with ESA's really amazing Sentinel-2 constellation of systems that will allow us 5-day repeat global coverage at 30-meter scale from 2013 onwards. And the last bullet point here is the manifestation of conflict or of violence that we're seeing in the landscape is really one of the last things that we might see after years, decades, perhaps centuries in some cases, of underpinnings of violence. So we could look at Johan Galtung's kind of conceptualization of different manifestations of violence on the right-hand side. What we're talking about is direct violence. We're seeing buildings being destroyed. We're seeing a whole-scale landscape change due to bombs and munitions being exploded. But underpinning that is cultural violence and structural violence, systematic exclusion, racism, things that also have an effect on the landscape that we could see and start monitoring well before actual direct armed violence results. So things like looking at the urban deprivation, or Doreen was talking about some of these aspects associated with monitoring slavery. These are all manifestations of different forms of violence that we could have a better sense of with these long-term repeat views. Next slide, please. Currently, what is being done in the humanitarian and the conflict monitoring realm, while these imagery have their place, most of the work, as Einar was mentioning, is really with these half-meter, sometimes up to 3-meter commercial satellite imagery. As he mentioned, there's challenges around access to these data. There's challenges around the technical bar in engaging with these different data sets. That can limit some of the decentralization work, right? So there's a certain group of people around the globe that are tasked with some of this work, and it would be perhaps a very different mode of operation if we had open access to these very high-resolution imagery and a fully decentralized approach to this monitoring approach. We're not nearly there, but we're all working in that direction to try to bring different voices to these kind of analyses so that it's much more representative of the concerns of the global community. As I mentioned as well, most of the work right now is in the sort of detection rather than monitoring. Detection is critically important, but when we are interested in long-term processes, transitional justice, peace building, which could take decades or generations, we need to have the history, and we also need to have this repeat sort of monitoring approach to better understand these things, rather than just individual events or perhaps 1 year to the next, which are critically important for aid and humanitarian relief, but perhaps less helpful for transitional justice. And last, just to echo Doreen's point, there has been a successful charter introduced, the International Charter on Space and Major Disasters, to standardize approaches, deliverables, and expectations for groups working with disaster and hazard response, things like earthquakes or typhoons, cyclones, volcanic eruptions. Different groups get involved, and in a very short amount of time, and a massive amount of data are generated and shared in a very transparent way. We could approach something like that with conflict monitoring, peace monitoring. Perhaps it's an overly political issue or seen as such, and so that seems to be a deterrent in doing this so far. But I agree with Doreen in thinking that this is really the way to go to sort of standardize across different efforts. Next slide, please. Thanks very much. I really enjoyed the presentation so far, and I look forward to the rest of the discussion.
Great. Well, thank you so much, Simon. I really appreciated the distinction you drew for us between incident detection and long-term monitoring, and really understanding how they can be complementary, but they do in the end serve different purposes and are more appropriate in different circumstances. So that was a really helpful way to look at it. Just a quick reminder, I'm going to go into a few questions now, but I also want to encourage everyone to participate in our interactive poll, as well as submit your own questions to our speakers. So again, please check out Slido. SDG 16 is the code. I want to now go ahead and just follow up on a few points that you all made during your presentations. I'll start with Einar. You've been working on this topic since the early 2000s. Can you elaborate a little bit how you think the field has changed? I mean, I think for some people this is a very new idea, but I think you can really speak to the fact that it's not. But I'd like to understand the deltas that have happened in the last few years. And I'm particularly interested in what you mentioned about the International Criminal Court. How is this data used in legal type situations? You know, has that also evolved?
Yeah, no, thanks for that. I think that one of the main, there are two main aspects here. One is the improvement in the level of details. I think it's absolutely right what Jamon was talking about, you know, that you need basically the whole spectrum of imagery. You know, the low resolution, wide area coverage going way back in time is important and very useful. What we have seen in addition to that, though, is that basically in terms of the level of details you can see in a satellite image from, you know, well, just before, let's say, 1998-ish, until today, you have like a 500 times increase in the level of details you can observe commercially. So, you know, that opens so much new opportunities. And I think it's something that we all should really benefit from in that sense. So the pure level of details that are able to one are now able to analyze is just astonishing compared to what it was back then. Of course, also with all the new constellations that are coming up, I think we're going to see much more use of the data. And here also, again, as I briefly mentioned, with the mini group, I think it's a type of democratization of satellite data today. So many more groups will be able to complement and validate and some maybe even argue, you know, analysis that has been done, and I think that's a good thing. So that is another aspect. And then in terms of the International Criminal Court, yes, they are really looking at using much more, let's say, forensic evidence in the way they prepare cases. And as part of this, may sound a bit strange, but satellite imagery is becoming part of this forensic evidence. So in terms of the International Criminal Court, what we are looking at now is to develop, or what we have done, is to develop standard operating procedures for how to best make use of this type of information within the court. But it's a learning curve, especially for us, also for them, I have to say, because it's new. It's and one thing is to you know, do an analysis, but you have to make sure that this fits into the correct way of preparing a case, of making sure that what you do is communicated in a correct way to the right instances within the court, etc. So it's definitely a learning curve, but I'm very happy to see that it's already been used for testimonies twice, and it will also soon be used again. So I think we're on the right track. And together, I think that the whole community, and it's definitely not only us. There are many organizations with good say capacities in this domain: Amnesty, Human Rights Watch, and others. So it's something that is definitely coming, and I think it's a very good thing, because we can use this technology to also hold those accountable for one of the worst crimes against humanity. We can all contribute to holding them accountable. And I think it's extremely important.
Thank you so much. That was a really helpful way to understand where we are in the process and where we're going. Doreen, I wanted to ask you about a topic that you touched on towards the end of your presentation, which is how we talked a little bit about this when we first met, but how the United Kingdom's approach to academic research really influences your lab's work, you know, who you work with, how you turn this data into action. Can you just elaborate a little bit more on what that looks like for your lab?
Sure, thanks for that, Crystal. And I have to say, I've never met Jamon before today, so the fact that we both came up with the same thoughts around having an international charter bodes very well. So that's definitely a spin-off from this this webinar. Okay, yeah, thanks for that question. I think I mean, as an academic lab in the UK, we very much adhere to what's called the Haldane principle. So whilst a lot of our funding does come from the UK government in one way or another, independence of thought is really, really important. So it is that kind of blue sky thinking that we are then bringing to bear on the problem that we're focusing on in the lab, which is to end modern slavery. So the lab itself is quite young. We're coming up to our third birthday, and so we've been very, very mindful of the UK, funding landscape and beyond. And within the UK, there's been two major influences in terms of the way we've approached the setting up of our lab and then how we've undergone our work. The first is that the UK government, around 5 years ago, committed to spending 0.7% of its GDP on international aid. So what that did was some of that funding, around £1.5 billion of funding over 5 years, was moved into something called the Global Challenges Research Fund, where research bodies could bid for funding. However, it wasn't for sort of blue sky thinking just for blue sky thinking sake. It was for projects that were co-designed, that were equitable, with DAT-listed partners. So it had to have an impact. It had to have a focus on helping a DAT-listed country. And what that's done is really transform a generation of university researchers into people thinking carefully about the work that they do, the research that they do, and how that will have impact, particularly in the context of international development. But of course, it does give them the space and the time and the resources and incentives to make that transition from perhaps doing research that would sit in journals and publications through to something that is useful. That's been a major drive for the work that we do. Another drive has been what's called the Research Excellence Framework Impact Agenda. So every 6 to 7 years or so, every research institution within the UK is assessed. So it's a peer assessment exercise run by the UK government, and we're assessed on our publication outputs, our income, but increasingly now about our impact. How is our work being used, and what impact has it had on culture, economy, the environment, and humanitarian issues and so on. So again, as an academic, you need to be thinking about, right, okay, I'm interested in X and Y, but how does that then benefit society as a whole? And so again, that's really set up the way that we run our lab, and having the Modern Slavery Evidence Unit interfacing out, outward facing with the stakeholders, has allowed me space to pursue this work, but then knowing that I've got somewhere to go with it, that it then goes out to the wider anti-slavery landscape. And for someone who has spent 20 years doing Earth observation, not in the humanitarian field at all, having that capability within the lab has really transformed the knowledge I have on using Earth observation data and moved it into something that really has impact on the ground.
Thank you. And that leads really nicely into my question for Damon. You also have a lab that does a slightly different type of work. You really laid out very well for us how lower resolution imagery can be used in a different way. Can you talk a little bit about your process about bringing, what is really, it requires a high level of geospatial analysis. You can't, not anyone can just pick up this data and start doing what you guys are doing. So how do you build action into your work? How do you work with partners? Can you talk a little bit about that?
Yeah, I think most of the projects that we've done have been really motivated or catalyzed by work that's done either by journalists or by NGO groups, rights groups, sort of raising awareness of different concerns that, for example, we have ongoing projects around studying refugee settlements and environmental degradation at refugee settlements, opportunities for improved settlement design. That work didn't come out of looking at an academic article. That work came out of work that has been around since early 2000s, when there are people from UNHCR and other relief groups were raising the alarm about basically the securitization of refugee populations, so-called warehousing policies that restrict refugee movement, migration, economic opportunities. So it really starts with, most of the work, I would say, starts with a concern that comes from outside of academia, that comes from people that are on the ground, that sometimes are directly affected by these different kinds of conflict processes or displacement processes in the case of refugees. And trying to position the work really in the same way that going to the gold standard, I think, that UNOSAT has set, where we try to be as fully transparent with the process, with the data, with the flow, with any sort of analytical routine as possible. Not only does that give you any sort of that on one level gives a sort of accountability, but it also opens up the decentralization, the democratization of this kind of approach, so that we can, take some of the work that we're doing here and package it in such a way and share it with others, so that it can be picked up, really not where we started it, but where we ended it. Along those lines, there have been, the data are always complex, right? The data that we're working with now are simpler than they've ever been, which is, the way it is. They're delivered more quickly. They're delivered with much more documentation, much more metadata, the kind of information you need to know about time of acquisition, solar illumination conditions. There's more there than ever before. But the challenge is still the algorithms, it's the processing, and it's also knowing the right way to how to undertake the analysis, and what are the best sort of safeguards to having a confident result, so you don't have false positives and false negatives, to keep in mind the different counterfactuals that you need to be aware of. One thing that has really streamlined a lot of that analysis for the work we do are open access analytical platforms. Google Earth Engine is the principal one that we use. It's open source geospatial technologies that we've really benefited from, and the global community that's built up, that several years ago was a couple of thousand people around the globe, and it's now tens of thousands of people using similar kinds of data sets, using similar kinds of algorithms, and supporting each other and helping each other. It's something that we wouldn't be able to do our work without. It always is standing on the shoulders of giants, right? That's always learning from other people that have come before you, and we're trying to do our best to engage and share not just the data sets and derived products, but the kind of framing, the theory, the motivation, the perspectives, and be as clear as we can with that, so that it's not just a map that lands on your door, but is sort of a culmination of it's a solidification of a perspective, and hopefully a much more direct contribution in that way.
Great, thank you for that. I want to move next to the interactive portion of our work today, because we have a lot of great questions and comments that are rolling in, as well as the responses to our poll. So I'm going to switch to that so that you can all have a chance to look at this. And so, several of you have hinted at what are the obstacles. And so we put in a poll from the beginning saying, what does the audience, who's a really mixed group, at least based on my scan of registrations, what is their perceptions of the obstacles? Because that's something we really want to hit on this series. It depends on where you're sitting. Sometimes it's the technology, it's understanding how to do the analysis. Sometimes it's having the data, but sometimes you have the data, but the funders are concerned that this is not the right kind of data. And so I was wondering if anyone, I think all three of you can see the poll results, but so, does this, it definitely came out on top that the lack of political motivation to shift policies based on new data is the perception that might be the biggest obstacle, that you can do the analysis, but does it really affect change? And so I was wondering, does anybody want to comment on that, or any of the other potential obstacles listed here that you've talked about? Go ahead, Einar. You're muted.
Yeah, thank you. I think it's quite interesting to see this. Lack of political motivation, absolutely. I think it's clearly there. But it's with the same as with anything else, you know, unless we can convince the politicians and those making the policies that this is useful, then it will always be like that. It's sort of conservative by nature. And I do think that that in combination with what is there as number two, lack of funding, if you can show that this is actually cost effective, then you also have a very good case, because it's not only about the evidence, it's also about the cost. And if you can combine those two, informing more on what you are able to do with this technology, but also taking the costing issue into account, I think, yeah, you have a good chance of success. Because if you can do, you know, if you can cut across and make sure that people, policymakers understand the benefits of this, and also understanding that this is actually, in many cases, very cost efficient, then I think you are on the right track. But it will take time.
Doreen, did you also want to comment?
Yeah, thank you. Sorry, I lost you for a moment, but I'm back now. I mean, this doesn't surprise me, but I think as a neo scientist, I think sometimes we're guilty of assuming that the recipients of the data understand what we've done, you know, the challenges around what we've done, and I think we need to perhaps be a little bit more transparent about, you know, all we've done is really, you know, cool cutting edge methodology, and we've got this. Okay, so, you know, how have you validated it? What does it actually mean? You know, so the metadata actually associated with any sort of derived product that we can provide needs to be thorough. And I've seen lots of examples of derived mapping and monitoring where the metadata just aren't there, or are really, really complex and pages of documentation to go through that, you know, unless you're really, really committed, you're not going to do that. So I think there's a conversation to be had around, you know, perhaps some sort of data standards that specific to this particular field might be needed. So thinking about what does the consumer, for want of a better word, need to understand about the data, and therefore as a supplier we need to make sure that we're providing those that information. I think we also need to be challenging policymakers around sort of dealing with uncertainties. I think Ina mentioned it earlier, that using uncertain data doesn't mean that you're going to have, it's not a problem. You just have to understand that data are uncertain, therefore you need to back it up with perhaps more certain data or some other ways of making decisions. So decision making around using uncertain data, I think, is an important initiative. But what's really important to understand is most of the world isn't mapped. You know, we don't know about everything that's going on the ground, and this is the, you know, the biggest advantage of Earth observation data, and it's timely as well. I mean, when I think about my PhD, a long time ago, I was using data that was 1 kilometer in spatial resolution. So each pixel was a kilometer by a kilometer. And I was trying to do a temporal sequence. I think I got 1 image every 2 years. You know, we've moved way beyond those days, and we're getting that update much more rapidly, usually through with constellations, but that's fine. And the image providers are providing us data that has been processed to a level that actually all you need to do is analyze it for what you need out of the data. So, you know, the information extraction. So I think it's a really, really exciting time for Earth observation. And I think we have, it could be an easy job. I think it will be a challenging job to So let policymakers know that, you know, these data will provide you with what you need. We just need to have that conversation about, you know, how it needs to transfer across from the technologists, if you like, to the policymakers.
Great. Well, now I want to go directly to some of the direct questions that we've been getting. I'm going to start with one that I think is really important, that it kind of builds on what we were just talking about. What are the ethical concerns, privacy, security, anonymization, that should be considered when talking about this type of work in support of SDG 16? You know, how does your organization take into account that this data could be used in a potentially negative way by putting it out there in the world? You know, what are your concerns with, and you know, a lot of this isn't necessarily looking at individual people, and yet a lot can be surmised from it, which is why it's useful. So how do you approach the ethical questions? Damon, did you want to maybe start that one off?
Sure, yeah. Yeah, just to directly answer, yeah, there are certainly ethical concerns when using Earth observation for these kind of applications. I think some of the biggest concern would be, and this is of course played out with the experience of different humanitarian groups, where they do publish a map, they publish a location, they publish a map showing a location of change, and then, you know, for a armed conflict group takes that map and then acts upon it in some way in their own self-interest. They exploit that data, or you know, a worst case scenario would be having a map of a displaced and still very vulnerable population being published, and then the group that was responsible for displacing that population in the first place sees that map and sees that new settlement and then acts upon that. Those are really concerning situations. Some of that, of course, there's always some margin of complete uncertainty about how people will act, and an unknown about how they would make use of these new kind of data. But it's quite interesting just to, you know, to put this in the very, you know, right along with the news cycle is the United States taking a step towards removing the Kyle Bingaman amendment, which is the step that the amendment that restricts the policy, the resolution on American commercial satellite sensors over Israel and Palestine. Originally, it was capped at 2 meters, and it seems like it's going to be kind of opened up to about 0.5 meter resolution, 0.4 meter resolution. There are concerns expressed by the Israeli government over that restriction, by that, or the lack of that restriction. Now we have much more visibility. We have much more awareness and spatial explicit information that different groups could use in carrying out. The concern is that they could carry out certain sort of attacks. Now the perspective, this becomes an ethical question then. Is this ethical to give such high resolution data? This of course is all nested within geopolitical relationships, but at the core of this is a fundamental question. Is it ethical to provide that level of detail, knowing that there are people that could make use of these data to harm other people? In this case, it happens to be a very specific Israel-Palestine relationship, but the question writ large is much more, of course, affects everywhere. And the response, seemingly from the United States government, is that, well, the data are already out there. What are we doing? What's the point of having this restriction? There's already sensors that provide this kind of information. So it's a bit of like wiping your hands of it. It's already out there. If they want to get the data, they can. In the Libyan Civil War, there is a quote to a general in the New York, that was published in the New York Times, where he said, "We don't use any, we don't have any like geospatial experts. All we use is Google Earth." That to me is no motivation to shut down Google Earth, but there are always nefarious actors that are exploiting all kinds of information and data that are meant for good. The key thing that we have a responsibility as an NE is to do no harm as best you can, and really to talk to people that are going to be directly affected and that are working with communities on the ground that are much more in tune, for example, than I would be with understanding about how the data could be used in certain capacities. And there myriad safeguards that could be put into place, but I think it's not the last thing you want to do is hold on to it and then dump it out into the world, right? There has to be a sequence of chains. And I'm sure Einar and Doreen have many better examples of engaging with groups than I do on this process, but it's I would say, you know, communication and deferring to people that know much more than I do about the specific context that the geospatial product could kind of be engaged with. But so I'd be really curious to hear your 2 points too.
Einar, any comments on this? How does your organization approach ethics?
Yeah, no, thanks for that. It is a very important topic, of course. Basically, it boils down to the fundamental humanitarian principle of doing no harm. So when we are requested to typically by our sister agencies, it can be UNOCHA, UNHCR, the Refugee Agency, or other entities, what is absolutely there at the core is that you know, our analysis should do no harm. So that means that, you know, whenever we publish something, it's always cleared with the requesting agency. In many cases, it's okay to share the information, and it's good to share the information. And we can do that through maps. We can do it through, you know, simply sharing our own data on the Humanitarian Data Exchange platform, for example. So there are many aspects that you need to take into consideration before doing that. But we do have, I would say, that basic principle of do no harm. So if there is a chance that especially if the information we provide is so operational that if it falls in the wrong hands, it could be misused, definitely we will not put it online. And we have today fairly secure ways of transmitting this type of information to those individuals, and often it boils down to individuals that need the information. So we try to adapt that strategy. I would also say that the International Committee of the Red Cross has done quite a bit of work on this. They have publications that links to ethics and geospatial information and ethics and in let's say conflict situation, of course. So there is definitely material out there, but for us it boils down to really listening to what our agencies that have, you know, the boots on the ground are saying, and if they say no, definitely it's a no. If they say this is fine to share, we share. So that is a bit the approach that we are taking. But of course, this is evolving, and sometimes also for very sensitive matters, of course, you know, there's may not be the sharing may be no more harm than good, especially if let's say there's peace negotiations happening and things like that. So it all depends also on the timing, and we try just to use, of course, keeping ethics very much in the forefront, and then combining that with simple, simple, I would say, common sense as well when you do this. So, but listening to our sister agencies and our and their opinions is absolutely fundamental in this aspect.
Great. I want to turn to another question that touches a little bit on something Doreen mentioned earlier. And I'm not sure there's an easy answer, but the question is, what is your opinion about the need to define standards for mission and evaluation of remote sensing evidence? And this kind of speaks to a specific situation, but you know, what if someone doesn't know much about this? What standards are out there? What standards do we need? I've heard a lot of talk about looking into, you know, the licensing issue, which we haven't really touched on all that much here. But I'd just like to get your opinion on, you know, what do you think the next steps in terms of standards and the rules behind the processes are needed? It sounds like a lot of organizations sort of do what they need to do on their own, but is there a need for a larger effort? Doreen, I'll start with you.
Okay, thank you, Crystal. I thought I'd open a can of worms if I mentioned standards. There are many standards out there for geospatial data. So, you know, we're not starting, you know, from a standing start, as it were. But if I were to use an example of simple land cover mapping, so to produce mapping of the UK, where your urban areas are and where your agricultural areas are, and so on. Just something simple as that. It's amazing how many maps are produced like that don't have things like the accuracy assessment of those of the mapping, and it's one of the first things you learn as an Earth observation scientist is how to validate and provide an accuracy overview of your mapping. And so, that's a simple first step into, you must do this in this particular way, using a particular sampling regime with a set number of samples, or an equation that you can plug your particular example into. So we're trained to do this sort of thing, but sometimes in getting the information out to the recipient, we forget. So I think it's just reminding everyone involved what should be included, and then but making a standard that is explicit to this particular community, and learning from the standards that have gone before within the geospatial community as well.
Great. Any other comments on that? I don't see any virtual hand raising. It's a tough question, so I think there's a lot of room for further discussion there. The next question that I want to go to, let me scroll down, is one that I think represents a question that a lot of people have. So I can't seem to get to it online. There's a question online about, where do you go? So the question actually says, are there data portals for satellite and remote sensing data? Can data sets be used by data analysis without proper training in remote sensing? And I kind of want to add to this question, because it was sort of how I intended to end this event anyway, which is, I'd like to hear from each of you. What is your advice to someone listening to this who isn't already doing this? Right? So whether they're a data provider who's very interested in making sure that their information gets in the hands of and is used in this incredibly valuable way, if you're someone who's designing a satellite and you want to make sure that you're taking in use cases, or if you're on the other side and you're a government or you're an NGO who wants to take advantage of this technology, where do you start? What does that look like? What are those pathways for collaboration and accessibility? And so I think Portals touches on that, but it can be a little bit of a larger question. Einar, I'll start with you.
Oh, it's a big question. It's, I think, there's a lot. Obviously, there's so much information out there, and so it can be a bit difficult to know where to start. I think you need to really reflect well over what you actually want to use this for, and then you need to find, to do the, let's say, find the information that you need for that. For example, if you are interested in making use of this information yourself, there's free and open source data, there's free and open source software with free and open courses online that you can take in order to become familiar with the software, and you can fairly quickly become an image analyst yourself even. So it's that aspect. But then of course, there are if you're a government user that would like to make more use of this type of information for the SDGs, let's say in general, including SDG 16, yes, there's a lot of data out there. There's a lot of information, but it can be challenging for them to know where to go. And I see that I often meet government employees, and they have heard about let's say geographic information systems, remote sensing, but they're a bit hesitant as to how to become how to make use of it. And I think again, this is where the community has sort of failed, but not reached its full potential. Is that we've been so much focusing on providing satellite imagery, but what governments need is not satellite imagery. They need information products. They need information products that they can make use of right away, and I think that is what is lacking a bit today, and that is sort of a gap there between being able to provide imagery, but instead being able to provide and feed up-to-date information that they need so that they can take it straight into the decision-making processes. So it's not an easy answer to this, but I do think that definitely there's we see a huge surge in availability of free and open source data. And as I mentioned also earlier, even commercial data dropping significantly in price. So I think that it's very important to take time and try to describe well what one need this information for, and then there are solutions out there. And if there are no solutions out there, then hey, it's an opportunity to actually develop something new. So yeah, I think I'll stop there.
Okay. Simon, what are your thoughts on this? Is this about more public-private partnerships? Is this about individual organizations just building out their capacity? What do you think?
Yeah, it's a good question. I agree with everything Einar said. I think definitely the place to start is what's the gap that you're looking to fulfill? What is the specific opportunity that remote sensing data offer that no other data source provides or doesn't provide in a satisfactory way? That's the key thing, right? What's your need? That should help constrain all the different things that follow. I guess my thought was in individuals thinking about and groups thinking about starting from this. I think a great place to start is to look at what UNOSAT's been doing and to look at what Doreen's lab has been doing and to look at what Harvard Humanitarian Initiative has been doing. And PAX and other groups, Amnesty International, that have been working with these data in really cutting edge ways for, in some cases, almost 20 years. That's the grounding, I think, and not only does that help frame the kind of an understanding of the questions and the problems that have been solved, but certainly the methodologies, the data sets that can be used. I think there ends up being a sort of hurdle inevitably with like working with the data, having the proper sort of analytical understanding to engage with the data. And that's where online communities and different sorts of user groups are really important. That's where I turn to all the time, people that are working on these kinds of topics and just seeing the kind of work that they're doing, whether it's through Twitter or whether it's through different kinds of online webinars. NASA runs Surveyor, which is an online open training platform that spans multispectral data, radar imagery. And Einar mentioned as well, there's lots of online classes through Coursera, different kinds of MOOCs that could be taken. So I think that's sort of getting your feet wet, working with the data, especially in an open source way with an open source community, is a great way to start. And not making it overly complicated right away. Have fun with it. Try to make a video animation. Try to make something that just like looks pretty. Doesn't need to be amazing data. Doesn't need to be amazing science. Make it look interesting. Manipulate all these different bands together. There's the ESA Sentinel Hub is an amazing resource for this. I don't know of a better site that allows you to just play with data without downloading gigabytes of data. You can play with it through your browser, and it's really amazing, and it really opens up your eyes to different sensitivities that different systems offer band by band, and how different systems see the landscape differently. So I totally agree. We're still not there yet, but there are more resources than ever before at lowering that threshold to get more people involved.
Yeah, I think that's a really good point. When you highlighted a bunch of other initiatives, we had in some ways, this is a huge field. In some ways, it's very small. You guys have referenced several other groups that have been doing amazing work in this area. And there is a lot out there. There are a lot of resources. There are a lot of people to talk to. I also really liked your point about sometimes you can start small. I think we've all really seen, especially in journalism, but in a lot of other areas, the value of visualization and the ability to put something on a map and to show people is so much more powerful. And yes, sometimes you're going to need to do really complicated analysis to get to really good data for very specific situations. But there are plenty of situations that don't require that, where you can really show something where the data itself is relatively simple in a way that helps people understand. So I think that's a really good point. Doreen, are you still with us, or did we have an internet connection? Did you have any comments on this?
I am here. Sorry. So this is the question around satellite and remote sensing data portals or analysis.
Yeah. How did someone get started?
I don't know whether anyone's mentioned Google Earth Engine. I think I kind of feel like that I'm redundant now with the Google Earth Engine, because the data availability through the portal is amazing now, and you can do some very simple analysis through to really quite complex analysis. So just have a play with it. It's open source. There's other open source data and portals out there, and processing packages. Jamon mentioned the Sentinel Hub. That's a really nice way to start as well, and that's all open data. But equally, some of the proprietary pieces of software, the Esri software will use, and you can process satellite data through that package as well. So it's definitely not as exclusive as it was, and we talked about democratization to some extent. I think we're certainly seeing that with satellite data now. It can be in the hands of anyone who has an interest. But I think as an academic, we have some work to do again in making processing of EO data, or the awareness of it and its capabilities, putting that into all sorts of degree courses and filtering down into schools as well, so that everyone graduating realizes the possibilities that are there.
Great, absolutely. So we've highlighted a lot of examples. We have another one highlighted on the screen from Andrew Zoli at Planet, and about their work to establish a distributed human rights observatory similar to what we had discussed previously. So I just encourage everyone to realize that we've tried to touch on a variety of projects here using different types of data for different purposes, but this is hardly this is just the tip of the iceberg. And so we see this as an opportunity to have a discussion about some of the issues and encourage everyone to take a look, and if this is applicable to what you do in one way or another, to reach out to the internet does have a lot of resources. I'm going to try to capture later on when we write up this event a lot of the ones that our speakers just mentioned, because I think that is an incredibly valuable list if you're not as familiar with that. So we are running out of time. I do want to thank, first of all, our wonderful speakers today. I really appreciated the depth and breadth of examples and ideas and thoughts that you brought to this. I really appreciate you taking the time to have this conversation with us. Secure World is focused on space sustainability. We care about how people use data because we think it's important, and that's why we want to have space sustainability, because of the work that can be done with space data. And so to see these examples of that and to see how the field is progressing is incredibly exciting. So thank you so much today. I also want to thank our audience. I can't interact with you directly, but I'm really excited about the enthusiasm that we've received so far in this series. We have 4 more events. Encourage you to participate in those, to reach out if you have ideas and thoughts on those as well. We're very excited, and we will also be posting everything publicly. So that's kind of the note that I want to close on, is this is not a one-off opportunity. We're very interested in continuing these conversations beyond the webinar series. But more importantly, or not more importantly, but importantly, we also want this to be something that if you couldn't happen to join us for this discussion today, it doesn't mean this information goes away. And so if you think that there's someone out there who can benefit from this, we will be posting it. Our previous event on food security has been shared online, and we will continue to do that throughout this series. So thank you all very much for your time today. It's exciting to be here with you, and I look forward to your comments and questions and feedback afterwards. Thank you so much.